Welcome to The Explainer. Today, we're firing up a topic that's absolutely critical for your comfort and, more importantly, your safety at home. We're talking about your heating system.
You do it all winter long without a second thought. But have you ever wondered what really happens when you nudge that thermostat up? That simple click, it sets off this whole fascinating chain reaction of fire, air, and physics all happening just out of sight.
So we're going to strip away all the complexity and take you on a quick tour, kind of like what an inspector would do. Our goal is to give you the essential knowledge to really understand how your home stays warm, what to watch out for, and, this is the big one, when you absolutely need to call a pro.
Okay, so first things first. It doesn't matter if you have a brand new furnace or an old boiler. They all, and I mean all of them, work using the same three fundamental parts.
Think of it like this. Every system has three main jobs. First up, the heat source. That's the engine, right? The furnace or boiler that actually creates the warmth. Second, you've got the distribution system. Think of these as the highways, the ducts or pipes that deliver that heat to every room. And third, the controls. This is the brains of the whole operation. We're talking about your thermostat and all those vital safety switches.
So how does that warmth from the furnace actually make it into your living room and, warm you up? Well, it all comes down to three basic ways that heat moves around. Once you get these, you'll understand your entire system so much better.
First up, we've got conduction. This is just heat moving directly through solid objects. The classic example is a metal spoon in a hot bowl of soup. The handle gets warm, right? Even though it's not in the soup. In your house, heat conducts right through your walls and windows, which, by the way, is exactly why good insulation is so important.
Next is convection. This is all about heat moving through a fluid, and that includes air or water. If you've ever watched water boil, you've seen it. The hot water rises, the cooler water sinks, and it creates this rolling current. That is precisely how a forced air furnace works. It heats the air, and then a blower creates a convection current that flows through all your ducts.
And finally, there's radiation. This is heat just traveling in invisible waves. You don't have to touch a campfire to feel its warmth, do you? That's radiation. Things like radiant floor heating and those old-school cast-iron radiators, they warm your rooms in exactly the same way.
Okay, now for most of us with gas or oil systems, the heat source relies on a very specific, very controlled process. We're talking about the fire that's literally inside your furnace. Combustion.
Now, at its core, combustion is a really simple formula. You take fuel, you add oxygen, and you get heat. But, and this is a big but, it also creates byproducts. And how your system deals with those byproducts is where safety becomes absolutely critical.
Believe it or not, the color of the flame inside your furnace is one of the most important clues you have about its health. A healthy, happy, efficient flame is blue. But if that fire is starved for oxygen, you get what's called incomplete combustion, and that produces a lazy, dangerous, and inefficient yellow or orange flame. If you ever see a yellow flame, that is a major red flag.
See, that yellow flame isn't just wasting your money on fuel, it's producing some seriously deadly byproducts. And the most dangerous one is carbon monoxide, or CO. It's an invisible, odorless gas that can be fatal. This is exactly why the venting on your furnace isn't just some optional feature, it is a life-saving necessity.
Getting those dangerous byproducts safely out of your home is, without a doubt, the most important job of the entire system. And how your furnace does that depends on its efficiency, which puts it into different categories.
Now, let's just focus on the two types you're most likely to have. Older, standard efficiency furnaces are what we call Category I. Their exhaust is super hot, around 300 degrees, so it naturally wants to rise up a metal chimney. This creates a negative pressure that basically sucks the fumes out. On the other hand, modern high-efficiency furnaces are Category 4. Their exhaust is way cooler, so it won't rise on its own. Instead, a fan creates positive pressure to actively push the fumes out through a plastic PVC pipe.
So here's the one thing you really need to remember from all that. Older systems pull hot gas up a metal chimney. Newer systems push cool gas out a plastic pipe. That is the fundamental difference, and it's why you can never ever mix and match parts between them.
Okay, we've covered the science, right? Now let's turn all that knowledge into a super practical checklist. Here are the key warning signs that you, as a homeowner, can actually look for yourself.
All right, first up, yellow or orange flames. We just talked about this. That's a sign of dangerous, incomplete combustion. Next, look for soot or rust stains around the furnace itself. That could mean exhaust is leaking out. If you see water leaking, especially from a modern unit, it could mean there's a serious clog.
Any loud or weird noises, like squealing or banging, definitely point to a mechanical problem. Now this one's really scary. Bypassed safety switches. If you see strange jumper wires that look out of place, someone may have disabled a critical failsafe. And finally, just take a walk outside and make sure your vent pipes aren't blocked by snow, leaves, or anything else. If you spot any of these things, turn the system off and call a technician. Seriously, immediately.
So there you have it, a whirlwind tour of the science and safety behind your home's heating system. You're now a much more informed homeowner. So the only question left is, what's the first thing you're going to go check?